It is really easy to apply class weights with Keras, and we will use the fit generator function, and we will use the same principle, the principle that we used in class weights to calculate the weights of the class or importance of the class. And I want to show you some documentation from scikit-learn. In scikit-learn, the way that calculating the class weights are the same with our example. So maybe you are familiar with NumPy, and actually it calculates the class weights according to the same calculation. And let's see some academic papers. Or you can analyze it, or you can search for it by looking this article. They all scikit-learn functions that has a mathematical background has some references, and you can check it. I don't want to go into detail with it because it's an easy concept, and also to apply class weights to Keras it will be easy. However, we need to first calculate the weights for class cat and class dog. So I want to indicate that we have 300 images for dog and 1000 images for cat, and let's calculate the class weights with our function. It is actually really easy, and number of all samples minus our class and number of all samples, and actually number of all samples minus the class that we want, the number of the samples of the class that we want to calculate its ratio, and it's divided by number of all samples. So in our case we have 1000 images for cat, and also 300 images for 300 images for dog, and number of total images, number of all sample is 1300. And to calculate the dog, what we should do is 1300, so we need to subtract it by 300. We want to calculate the weight of the dog, and we want to divide it actually. So one of our class weights will be let's say that this is 1000. So one of our class weights will be 1000 over 1300. Actually, we can do something like that. This won't be a problem. So, and also for the deck data, for the cat category, it's clear that it's 3 over 10. So to apply class weights in Keras, in fit generator function, we need to add a new parameter, which is class weights. And also, well, our format to organize class weights is we need to have dictionary, and in our dictionary, well, you can think that what should I write here? So we calculated the class ratios, and how do we know that for example 0 is the, let's write the format of it. We have the order of classes cat and dog, but we don't know the order of Keras, order of training. So we don't know that cat is the first category that is analyzed and trained by Keras, so we are not sure of it. So the format is actually, let's say that we thought that our first element or our first class is 0 and our second class is 1, and we thought that 0 is for dog and 1 is for cat, and we thought that this is the correct way. But how do we know that? How do we know the order of training? Actually, your Keras assign numbers to each class, and we will be using it for prediction part. And to see how Keras ordered the classes, let's say that print train flow dot class indices, and also let's see the same value for validation data. And now actually we have 3 over 10 for cat, 10 over sorry, why it's 3 over 10, sorry, 3 over 13 for cat, 10 over 13 for dog. And let's delete it, we know the calculation. And let's delete this. When before training, well, we have problem here. Why it is a problem? We forgot something here. Well, before training, we need to check that 0 is for one class and 1 is for another class. But to know which are those, we need to write trainflow.class indices. Actually, this is enough, but I want to show you that both train flow and val flow will indicate the same order. So we see that before going into training, we see that cat is assigned by 0, dog is assigned by 1. So in the dictionary, we will use the same thing. So cat is a majority class and its order is 0, and we need to change the class weight according to this. So for the cat we have 3 over 13, and also for the dog we have 10 over 13. So we organized the class weights according to this. So let's run and see the results at the end of the video. I will again pause the video, then talk about the results of class weights. Well, in first epochs, you see that the accuracy and validation accuracy is high. Also, when the time goes on, you see that you get high accuracy in training and also high accuracy in validation. But in test, enriching the data is better solution. It is actually a better solution. However, if you do not want to handle preparing the dataset, or if you have the problem of having a possibility to enrich the dataset or create the dataset again, well, this is a good method to apply. You can see that well, until that point, until here, I can say that class weight is a good solution, and you see that accuracy is high in training and validation. This is a method to apply. This is an alternative method to apply if you have in condition that you don't want to prepare the data, or you don't have a possibility, or you just want to see the result of your imbalanced dataset with a small solution, and you don't want to waste your time with preparing the data again. This is a good solution. However, the problem of class weight is actually the accuracy is fluctuating. So let's say that you want to train your convolutional neural network architecture in 8 epoch, and until 8 epoch you see that accuracy is very good, validation accuracy is very good, and then at the 8 epoch you want to train 7 epoch, and this is the thing that I mostly face with while using class weight. This is not the thing that I lie about. This is I don't know how many times that I'm facing with the problem of jumping accuracy, let's say. Well, let's say that you want to train your architecture within 7 epochs, and until 6 epoch you see that your accuracy is increasing enough, and at the 6th epoch you get a good accuracy and you get a good validation accuracy. Now you think that I'm free, this is very good, and even at the 7th epoch I get a very good accuracy, better accuracy than at the 7th attempt. At the 7th epoch you see that your accuracy is low to 50%. This is the problem of class fade, and actually this has some mathematical explanation. Uh, Maybe sometimes the class weights are bigger, and actually this is a method that you can apply, and class weight has a very easy solution, but it has some problems like fluctuating accuracies, and let's see what the error is. We have problem with Keras image data generator. I hope that it's not a frequent problem. I actually use lots of applications of Keras image data generating. This wasn't a problem. But the thing that I want to say about class weight is this is an option. You can apply it, but uh, your accuracy can jump, and you should actually save your weights after every epoch if you want. And this is a very easy option that should be in your mind.